Operating system manage memory resources to optimize memory utilization and facilitate effective program execution. Now, for instance, consider a scenario where multiple software applications are running simultaneously on a computer system. Each application requires memory to store its code, data, runtime variables, and many other things. The operating system allocates memory dynamically to each process, adjusting memory allocation based on application demands and system constraints. It employs techniques such as demand paging, virtual memory, and memory swapping to efficiently utilize physical memory and provide a larger virtual address space. By managing memory effectively, the operating system prevents memory shortage, reducing memory fragmentation, and ensures that processes have sufficient memory to execute without unnecessary delays or interruption. Operating system also manage input-output devices such as the disk drive, network interfaces, printers to optimize I/O operations, that is input-output operations, and minimize resource contention. For example, consider a file transfer operation initiated by user on a computer system. The operating system coordinates the transfer process. Like you want to transfer a file from C drive to D drive, okay, or C drive to any other memory device. Okay, so what you will do? Operating system will coordinate the transfer process. It will ensure efficient use of available network bandwidth or disk input output capacity as well as CPU resources. The operating system may prioritize I/O requests based on factors such as device availability, data urgency, and application requirements. It employs techniques like buffering, caching, and scheduling to optimize I/O performance and minimize the latency. Now by managing these IO devices effectively, the operating system maximizes system throughput, reduces IO bottlenecks, and ensures that programs can interact with external devices efficiently, enhancing overall program execution efficiently. So, in summary or in short, operating system ensures efficient resource utilization by effective program execution by employing mechanisms such as process scheduling, memory management, IO device management, and all the operating system like Windows, Mac OS, Linux, real-time operating system used in embedded system as well as critical application. Now the fourth point in introduction is what? Operating system also act as a conductor, orchestrating the coordination of computer system elements. Now here operating system manage the hardware resources. Okay, CPU, memory, input output. Okay, for what? To ensure efficient utilization, fair allocation among computing tasks. For example, consider a scenario like where multiple applications are running concurrently on a computer system. What operating system will do? Operating system allocates CPU time efficiently, memory space efficiently, as well as input output bandwidth to each application based on its resource requirements and priority. If one application requires significant CPU processing power, okay, then the operating system may allocate more CPU time to it while ensuring that other applications receive their fair share of resources. Now, these resource allocation ensure smooth and responsive operation of all applications, preventing resource contention and bottlenecks. Operating system schedules tasks and processes for execution, determining the order and duration of CPU time allocated to each task. Now, for example, in multitasking environment, the operating system switches between multiple running processes, allowing each process to make progress without monopolizing the CPU. Okay, किसी का No process can do monopoly on the CPU. Everybody will get the fair chance to execute. Consider a desktop operating system like Windows or Mac OS. User launches a multiple applications simultaneously. The operating system scheduler ensures that each application receives CPU time in a fair, timely manner, allowing user to interact with each application smoothly. Communication and coordination. The operating system gives this facility of communication and coordination between all software application and hardware devices and users. Now, for example, when a user interacts with a software application, such as typing something in a word processor. Okay, I have opened MS Word and I want to type something, so I have to use keyboard. Sometimes I have to use mouse also. Okay, so the operating system mediates the interaction by translating user input into command that the application can understand. Similarly, operating system manages communication between software application hardware devices such as sending print commands to the printer or reading data from your pen drive or disk drive, or it provides unified interface for applications to access hardware resources, abstracting away the underlying hardware complexities. Okay. Operating system also handle errors and failures gracefully, ensuring system stability and reliability. For instance, if a hardware device malfunctions or a software application crashes, the operating system detects the error, isolates the affected components, takes the appropriate measures to prevent system-wide failures. Okay. Now, for example, consider a server operating system like Linux running a web server. Okay. If the web server encounters an error, such as memory leak or network timeout or anything else, what operating system will do? Operating system can restart the web server processes or switch to a backup server instance to maintain uninterrupted service. In summary, operating system act as a conductor orchestrating the coordination of computer system elements by managing resources, scheduling tasks, facilitating communication and handling errors. Okay, so this is about introduction to operating system.